Exactly 10 years ago, a Lorentz Center workshop was run called Jointly Designing a Data Fairport, where the FAIR principles were originally conceived. Now, 10 years later, in another Lorentz Center workshop called The Road to Fair and Equitable Science, we reviewed the FAIR developments during the past decade with 60 experts from around the world and considered the challenges ahead in the next 10 years. In this video, we give a brief overview of our findings. The hourglass image on the workshop poster is a reference to the Internet model, which has taught us to concentrate on minimal open standards that sit at the center of the hourglass. This leaves maximum freedom to implement both above and below. In the context of the web of FAIR data and services, the waist of the hourglass represents the meaningful machine actionability of information. Within the hourglass, we see that the world is upside down, but at some point, the hourglass is turned around so that everything is in place again. We decided on this design because we believe the global north and south should mutually contribute to this web of FAIR data and services, as well as mutually benefit from it. We should not widen the digital divide, but rather close the gap. This focus is also reflected in the term equitable in the title of the conference. The Lorentz workshop ran for 4 days, with findings presented to a larger group of stakeholders on the 5th day. The first day of the conference reflected on the past decade of FAIR. Days 2, 3, and 4 were reserved for careful consideration of 3 related focal areas: meaningful machine actionability at the center of the hourglass, equitable contribution, access and reuse of data and services, and finally, AI readiness of data and services, where any AI model will benefit from FAIR machine actionable data. On day 5, we opened the discussion to additional participants from many different disciplines and backgrounds to jointly consider the next 10 years of FAIR development in these 3 areas. Here is a summary of the key conclusions. In the previous decade, FAIR has spread widely over all disciplines in science and throughout the world. We now anticipate that the rapid technological diversification of FAIR supporting resources will evolve towards convergence in the decade ahead. Open science research infrastructures, such as the European Open Science Cloud and the African Open Science Platform, stated that they can only reuse data from other regions and domains if their implementations follow the FAIR principles. Unfortunately, the rapid global adoption of the FAIR principles have also led to unwanted side effects, such as misinterpretations that are now recognized as hurdles on the road to FAIR and equitable science. Meaningful machine actionability, where information is rendered unambiguous for both machines and people, forms the foundation of interoperability in an inherently distributed and diverse data ecosystem. We considered how meaningful machine actionability goes beyond machine readability as such and requires actual meaning, where computational agents and humans will be able to seamlessly work with data and services. We also reviewed the diverse array of approaches to machine actionability that have emerged, and, based on these examples, we have defined the relevance of and the need for different levels of machine actionability. We identified various stakeholder communities and discussed how they might contribute to technological convergence, with agreements on minimal specifications residing at the center of the hourglass. There was a clear consensus that wherever possible, proven, open community standards should be used. Equitable contributions to the data and services landscape, as well as access to data and their reuse, go beyond machine actionability itself as defined by the FAIR principles. Equitability addresses the higher level principle where anyone, be it a person or a computational agent, having a question that does not violate explicit access conditions and following legal or ethical frameworks, should be able to reuse data on equal terms. Finally, we discussed how achieving equitability can be actively enabled by adhering to the FAIR principles, where accessibility conditions should be machine actionable themselves and clearly spelled out as part of the complete provenance record. These conditions can be reviewed and potentially challenged by both machines and people. The accelerating and sometimes disturbing developments around artificial intelligence in recent years prompted a discussion of the role of the FAIR principles in both the development and the use of ever more complicated AI in society. The focus was on the ways for data to be rendered to allow machines to optimally reuse and learn from them. This included an examination of legal access to underlying data, including copyright infringement, and how constraints, such as the application of FAIR conceptual models, can be used to improve the output of artificial intelligence models and help mitigate hallucinations and the spread of misinformation. On the final day, we turned our attention to the next 10 years. To do this, we invited additional stakeholders from the public and private sector and jointly reviewed the main findings of the workshop: a proposed decadal roadmap towards fair and equitable science, specifically targeting 6 community stakeholders. Together, we took joint decisions on the publication of the roadmap and the desired next steps. Please contact us with questions or comments on the road to fair and equitable science.